Welcome, class, to our second section of Air and Water. I'm excited to be going through these pages with you. It's going to be pages 8 through 16. So make sure you're paying attention on screen and following along, or that you have your book with you and you open it up and follow along. Remember that we have checkpoints for your assignments for this section. And I think there's 4 or 5 checkpoints, and then you have your apply science. So before we dive in to our second section, let's review what we learned last time. What did we learn? If I scroll up a little bit, we can give you some hints. We learned about the 6 main factors or conditions of weather. We learned about the layers of the atmosphere. We learned that air is all around us, right? So let's review our 6 main factors or conditions of weather. And that is air temperature, humidity, air pressure, wind, clouds, and rain or snow. And then we had little sections about each one of those. Okay, so now let's get into where is Earth's water. Let's start off by reading the make a connection. So take your attention and let's look at that. It says, Niagara Falls is one of the largest waterfalls in the world. More than 3,000 tons of water flow over the falls every second. Where do you think all this water comes from? So that's our question to get our mind prepared for what we will be covering. Okay, and remember, a ton is 2,000. So 3 times 2, right? If we, little math lesson, right? This is how many tons of water there is. So if we do 3 times 2 is 6. And then we amend the zeros. That'd be 6,000 either pounds or tons of water, right? More than 3,000 tons of water, so 3,000. Each ton is 2,000 pounds, right? Pounds of water. So over 6,000 pounds. Sorry, let's. I totally screwed up that math. All right, let me pull up my Epic Pen really quick. Trying to connect this, right? So we have 1 ton is 2,000, right? I like to try to connect these things, so let's do this really quick, right? So we have 3,000 times a ton, right? A ton of water is 2,000 pounds. So like I was saying, if we can kind of just ignore these zeros, and I screwed up doing the amending, right? So 3 times 2, right? We'll focus on this. 3 times 2 equals 6. And then we amend the zeros. And how many zeros were there that we ignored? There were 6. 2, 3, 4, 5. Those are bad zeros, sorry. So there's 6 million pounds of water that flow over Niagara. Okay. There we go. Succeeded with the math lesson. Good job, Mr. Gowdy. Okay, so let's jump in. The blue planet. Astronauts have described Earth viewed from space as a blue planet. That is because about 71% or almost 3/4 of Earth's surface is covered by water. So here's a little picture here to the right. The blue planet. The presence of large amounts of liquid water makes Earth different from the other planets in our solar system. Along with air, water makes life possible on Earth. Water is an essential part of almost every living thing and a necessity for many life processes, such as digesting food and getting rid of waste. Plants and animals cannot live and grow without water. Water is also very important to Earth's environment, and in fact, some ecosystems are entirely in water. Water plays a major role in shaping Earth's surface by breaking down or wearing away rock and moving rock pieces to new locations, weathering and erosion, right? In addition, water greatly affects both day-to-day weather conditions and long-term climate patterns. People use water for many everyday purposes, such as cooking and washing. Farms, factories, and communities use water for irrigating crops, heating and cooling buildings, and fighting fires. Some power plants use the energy of flowing water to produce electricity. Ships transport goods around the world on water, and many people enjoy boating, swimming, and other sports. And so here on the left is some pictures of a few of the many different uses of water. And then right here is your checkpoint. So this is a little discussion post that you'll answer. Why do we refer to Earth as the blue planet? And you can refer back to the very first paragraph of this page to answer that. So salt water, we'll read this little section and then we'll look at this picture. So salt water, almost all the water on Earth, 97%, is the salty water of Earth's oceans. Little joke or little question for you, all right? Is the ocean salty because the land doesn't wave back? Only 3% of Earth's water is fresh water. Salt water is water that contains dissolved salts, mostly sodium chloride, the same substance as common table salt. Salt water is formed when water passes through land and washes out minerals from soil and rocks. Salinity is the measure of how salty water is. Earth's oceans. Oceans are huge, connected bodies of salt water. Remember, in salt water, it happens because the waves go into the land and they bring back minerals from the land, and that's why it becomes salty. So oceans are huge, connected bodies of salt water. Earth's 5 main oceans are the Atlantic, the Pacific, the Indian, the Arctic, can't really do that 4, and the Southern. So those are your 5 oceans. Water can move from one ocean to another. So together, the 5 oceans form one world ocean. Seas such as the Caribbean Sea are smaller parts of the oceans. Bays and gulfs like the Gulf of Mexico, so down southeast of us is the Gulf of Mexico, are areas of an ocean that are partly enclosed, kind of partly surrounded by land. A few lakes like the Great Salt Lake in Utah, place where I was just living at for a little bit in Utah, also contain salt water. Ocean water is too salty to drink or to use for watering land plants. However, the oceans are very important to people for other reasons. Many of our foods, such as fish and other seafood, live in the oceans. Other resources, including salts, minerals, metals, and fuels, are found in ocean water or under the ocean floor. So, even though we can't drink this ocean water, it's too salty for us, the ocean provides a lot of other important aspects or important things for us to live. So let's learn how the ocean water moves. We're going to be talking about the waves. The ocean is never still. It is always in motion. Waves, currents, and tides are all movements of ocean water. A wave is a rhythmic movement of energy through water or other matter. Only energy moves forward in a wave. The water itself moves in small circles. So if we look to the right, you can see these small little circles that are taking place. This is the water moving and energy passing through. The object floating on the water bobs up and down. Okay, so if you've ever been on a boat, you kind of feel that rocking. Most ocean waves are caused by the movement of air over the water. When wind blows over water, energy is transferred from the wind to the water. The energy then travels through the water in the form of a wave. The stronger the wind, the larger the wave it forms. Most ocean waves are less than 3 meters or 10 feet high. So that's why sometimes if you've ever been by the beach and there's really bad weather, you can see the waves are bigger. And that's how like tidal waves happen, is through the really strong winds. Occasionally, waves are caused by the movement of land beneath the ocean. Occasionally, waves are caused by the movement of land beneath the ocean water. Underwater landslides, earthquakes, and volcanoes can produce fast-moving waves called tsunamis. As a tsunami approaches shore, it can grow to a great height and cause massive destruction. Constant wave action changes the land at the ocean's edge, right? Because of the water coming in and pulling it out, kind of that weathering erosion stuff that we talked about. Waves wash away sand, wear down cliffs, and carry rock pieces to different places. In this way, coastlines are continually reshaped. So let's look at these few pictures and read its caption. So if we scroll back up and look at this first picture, if we read the caption, what does it say? It says, the energy in a wave moves forward while the water in a wave bobs up and down in a circular pattern. The wave's moving from left to right, and this energy is moving a circular pattern, making the water go up and down. What does this caption say? It says, some ocean waves travel thousands of miles before reaching land. Then, in shallow water, the waves break or collapse into foamy surf. Imagine a surfer going down through this, I can't remember what they call it, a pipeline or something. And then this caption says, continuous wave action where ocean water meets land is a powerful force that shapes and reshapes Earth's coastlines. All right, ocean water also moves in currents. Here's another vocabulary word, which are like huge rivers or warm or cold water that flow through the ocean. Warm and cold currents affect the temperature of the air above them, which in turn affects weather and climate. Warm ocean currents are one of the main ways heat is distributed from place to place on Earth. We can see these currents if we look at this page up here. The red arrows, if we look at our map key, the red arrows are showing these warm currents. And they seem to be really close to the equator, except for this one cold current right here east, or I guess west. Here's the California, so we're about right here on our map. So surface currents move at or near the ocean surface and are caused by steady winds moving over the water in the same direction. Earth's rotation or spin on its axis cause surface currents to move in curve paths. The Gulf Stream and the California Current are surface currents near the United States. Deep ocean currents are caused by differences in water temperature and salinity. Remember, the amount of salt in the water. Cold, salty water near the poles is so dense that it sinks to the ocean floor. Surface water is pulled in to replace it, in time also becoming cold and salty enough to sink. So kind of warmer water it gets really salty and cold, so it gets pulled down, and there's this pattern. In places where the water gradually warms or where winds push surface water away from the coastlines, the deep water rises to the surface. This action forms a current that slowly moves water through the world ocean like a global conveyor belt. At ocean shores, the water level rises and falls in a regular pattern called a tide. Most coastlines have 2 high tides and 2 low tides every day. Tides are caused mainly by the force of gravity acting between Earth and the Moon and the Earth's motion in space. And then here's your checkpoint to explain the similarities and differences among waves, currents, and tides. So you can reread that if you are struggling to answer that checkpoint and refresh your mind. Okay, we just have a couple more pages and we are all done. Okay, freshwater. Only 3% of Earth's water is freshwater, a water that contains very little salt. Freshwater is found in several kinds of places. So freshwater is found in glaciers and ice caps. About 2/3 of Earth's freshwater is in frozen glaciers and ice caps. So it is not easily available for use, right? Because it's frozen. But remember, glaciers are enormous masses of ice and snow that move downhill slowly. So frozen water is also found in thick sheets of ice called ice caps that cover large areas of land in Earth's polar regions, so North and South Pole. An ice cap up to 4 kilometers or 2.5 miles deep covers almost all of Antarctica, the land mass around the South Pole. There's also fresh waters and lakes, rivers, and streams, and they hold a very small amount of Earth's total fresh water, right? Because 2/3 is in the glaciers and ice caps. Lakes and ponds are bodies of fresh water surrounded by land. They form where water collects in low-lying places, so places that are below the land around it. Lakes are usually larger and deeper than ponds. The water in lakes and ponds do not flow. Rivers and streams, in contrast, are bodies of flowing water. They form as water moves downhill from higher ground, carving channels in the land, right? Weathering, eroding an area, forming the stream or the river. Small streams flow into larger rivers, which carry fresh water to the ocean. So if we look at this picture and read the caption, it says, a water soaks into the ground and slowly fills in cracks and spaces. The surface level of groundwater is the water table. We have the water table, we have our soil up here, we have rock, and the rock filled within the groundwater. So fresh water can also be found in the ground. And this is what this picture is showing. So let's learn a little bit more about it. In fact, much more fresh water is unseen and underground than is in the lakes and rivers on Earth's surface. So that's pretty interesting. So 2/3 of fresh water is in glaciers and ice caps. A little bit is in the lakes, rivers, streams, and ponds, but a whole lot of it is actually underground. Water that collects in the soil and rock underground is called groundwater. Soil and certain rock layers contain many tiny spaces and cracks. Fresh water from rain and from melting snow, like today, the snow that will melt, will seep into these spaces and cracks. Some of the water in soil is used by plants to live and grow. Other water soaks down deeper until it reaches a solid layer of rock that it cannot pass through. Then water backs up and fills in the spaces and cracks above. So that's what this picture is showing, right? The highest level of rock that is filled with groundwater is the water table. So right here is the water table. This area that isn't blue is meaning that water hasn't come back and filled this area. It's come down, but it's only filled up to right here. Much of the water that we use every day starts out as groundwater. People get groundwater by drilling wells into the region below the water table. Pumps move the water to the surface where it can be distributed and used to meet the needs of families, communities. Groundwater is an important source of fresh water that we use for drinking, cleaning, cooking, heating, and cooling buildings, water crops, carrying away wastes, and much more. So here's a picture, and the caption says, "In a tiny amount of Earth's fresh water is inside the bodies of living things, mainly in cells." All right, fresh water is also in the atmosphere. Some of Earth's fresh water is water vapor, a gas in the atmosphere. Recall that humidity is the amount of water vapor in the air. Humidity varies with time and place and depends largely on temperature. Fresh water is also found in the atmosphere, in a liquid and in a solid form. Clouds are clusters of liquid water droplets or solid ice crystals that develop at different heights above Earth's surface. So clouds are basically water, right? In different form. Fog is a type of cloud that forms from liquid droplets in the air at ground level. Water vapor in clouds are found mainly in the troposphere. Almost none exists in the upper atmosphere. In living things, a tiny portion of Earth's fresh water is contained in all the bodies of living things, and us. All organisms are composed of tiny living building blocks called cells, which consist almost entirely of water. About half of the weight of most plant and animals is water. For humans, close to 2/3 of our weight is water. Just like the Earth, about 2/3 of the Earth is water. Same with us humans, about 2/3 of our weight is water. All organisms require water for carrying out life processes, so water is very important. And it's important because it transports materials throughout the body. Plants also absorb water through roots, while most animals take in water by drinking. And then here is your checkpoint for Earth's fresh water. In what places is Earth's fresh water located? You can look at the title of the different sections in this to help you answer that. Okay, I think we have basically 2.5 more pages, all right? We're almost done. Quick lesson. So how water changes. Water on Earth exists in 3 different states or forms: solid ice, liquid water, and the gas water vapor. The state that water is in depends on its temperature. Earth's water is constantly changing state to respond to warming and cooling. Have you ever noticed that puddles disappear soon after a rain shower ends? The puddle water doesn't actually go away. Instead, as the liquid water absorbs heat from the sun, it changes to the gas water vapor and becomes part of the atmosphere. The process of changing from liquid to gas is called evaporation. Evaporation occurs more quickly when the air is dry or when it is moving. So here in New Mexico, where it's not as humid but it's more dry, water evaporates quicker, goes from liquid to gas faster. When water vapor cools or loses heat, the opposite occurs. It changes from a gas to a liquid. The process of changing from gas to liquid is called condensation. One second. I'm meeting with you guys right now in about 5 minutes to do a math lesson. So that's all I'm confirming, a math lesson. So thanks for holding on. And that's why I'm doing a lot of these recorded videos, so I can have more time to meet with those that want and need extra help. So sorry that I had to send a text really quick, but so we're learning about condensation. So condensation often makes the gas wet in the morning, even when it hasn't rained overnight. So sometimes when you wake up in the morning and go outside, and maybe the roads don't look like they're wet, but your grass is, that's because of condensation. Water vapor in the warmer air condenses into water droplets called dew on cooler exposed surfaces such as blades of grass or spider web. So right here is some condensation or condensed water on a spider web. Water also changes state between liquid and solid. Liquid water freezes to ice when the temperature falls below 0 degrees Celsius or 30 degrees Fahrenheit and melts back to liquid when the temperature rises again. When water changes from one state to another, the amount of water always stays the same. It's because it's either in that solid form, it could be liquid or frozen water, or it could be in gas. That's why the amount of water stays the same. And that's kind of what we're seeing right now with the snow. You have rain that's basically frozen into snow. And then here's your checkpoint. Under what conditions does water evaporate or condense? Under what conditions does water evaporate? And then also share under what conditions does water condense? Okay, this is our last section right here, the water cycle. Water moves from Earth's surface to the atmosphere and back again in an ongoing process called the water cycle. The same water moves along under and above Earth's surface, evaporating and condensing as heat energy is gained or lost. However, it takes a very long time for the same water to travel through the whole water cycle. Water may be stored deep underground or frozen at the bottom of an ice cap for thousands of years. The sun is the primary energy source for Earth. Energy from the sun powers the water cycle, causing water to evaporate into the atmosphere from Earth's lakes, rivers, and oceans. Water can evaporate into the atmosphere from moist soil and through plants. Water absorbed through a plant's roots moves throughout the plant. Some of the water is used for the plant's life processes, but most of the water evaporates through tiny holes in the plant's leaves. This release of water from plants into the air is called transpiration. Transpiration. Kind of like perspiration, but transpiration. As warm, moist air rises, it cools and the water vapor in it condenses on dust particles in the atmosphere. The water droplets that form are tiny enough to stay suspended in the air. Billions of these droplets group together into clusters called clouds. The tiny water droplets within clouds combine and grow larger and heavier. In time, they may become heavy enough to fall back into Earth's surface as precipitation. Precipitation is water in any form that falls from the atmosphere to the earth. So here we go. Rain is liquid precipitation, while snow, sleet, and hail are solid precipitation. And we just have experienced snow today, or those that are watching this on Tuesday, yesterday. Most precipitation falls as rain. Some precipitation soaks into the land and becomes groundwater, and some flows downhill across the ground as runoff. Both groundwater and runoff eventually empty into ponds, lakes, streams, rivers, and oceans. In time, the water evaporates and the water cycle continues. And then here is your last checkpoint, which is describe how water changes as it moves through the cycle. We have this awesome little diagram and water cycle with evaporation, energy from the sun taking the water into the air, putting it into a gas. Condensation, the warm, moist air rises and cools. And then we have our precipitation, with the water coming back and flowing back into the land, on the ground, into the lakes, the groundwater, the runoff. And then your apply science for this section is you may have noticed water droplets on the outside of a cold drink glass. Use your knowledge of how water changes state and explain it in the text entry box for your apply science, the source of the water droplets. So explain why a cold drink glass has water droplets on the outside of the glass. And that is our lesson for today. I will see you guys in the next science lesson, or maybe I'll see you in the next history one. Okay, see ya.